For my project, I decided to use Phil Heartbreaker Park and Salado Creek. I actually didn't realize how close they were, so when I found one, I found the other. When you first enter the park, there is a map that shows different trails, and I was going to do these, but I decided to just go off on my own and see what I could find, and I saw so many things that caught my eye. The first thing is this video. As you can see, it starts with just roots and trees, and as it progresses, you can see a rock wall, and on that wall, you can see different types of weathering. You can see biological weathering, and that is when the trees are coming out of the rock right there. And then on the same picture, on the left hand side, there is a small hole in the wall, and that is probably made by, again, biological weathering. More than likely, an animal has burrowed itself into it. In the next video, it is a small video, and you can see it looks as if there has been a landslide in three different areas. The first one was in the video, the last two are in the photo to the right. And I say landslides and not mudslides because these have the roots, it has dirt, but it's not clumped together like you would get in that clay of a mudslide. In this next slide, you can see that there is again biological weathering as well as chemical weathering. When I say biological, the circled line where the big root is coming out is example. To the left, there is a circle underneath. I believe that is from something called karst. I learned about Heartbreaker Park. I'm a little confused on what it is because we have not touched base on it in class. But the third thing I circled was that giant crack, which could have been caused be from this tree with the root going out to the side, but also to the left, that rock, you can see some small indentions that probably came from chemical weathering of carbonic acid. Continuing my way to through the park to get to Salado Creek Overlook, I noticed that there were tons of trees all around me. Obviously, most of the trees were sporadically rooted between each other, but there are a lot of trees in different stages of life. There were some brand new ones starting out. There were some that looked like they'd been there for a while. There were some that were fallen over and were in different stages of decomposition, kind of like the photos presented right now. This next one, and then this last photo that I'm showing you is a stump that looks like it has been obliterated by time. I gathered these wood chips from around that same stump. They were so brittle, and I assume it's because the wood is so dry that when I held them in my hand, I crushed them into dust. On the left-hand side, there is a piece of wood that has some holes in it, and I wonder if that is from carbonic acid. There is a chance it is, but again, there's not. Next is what I consider to be an ephemeral stream right here because it is about 8 feet long in total. There is absolutely nothing connecting it to it. I followed it up a good couple yards down and back, and I saw nothing that made me think that it was connected to a stream, a creek, a river, anything. You can see the shape of the bed, the creek bed, and you can see the roots and the rocks. The next one is rocks from our that were in that stream. You can see on this one rock the chemical weathering from the carbonic acid that hit that rock right there. The next photo that I have on the screen is a photo of what I'm not sure. Obviously, they're roots to something. They reminded me of grub worms. However, they are not. They are smooth and hard, and when you brush them in a downwards motion, however, when you go up, you do catch yourself on the small lip. I looked around the park. I didn't see them anywhere else. So I'm not sure what it is, where it came from, or what it has to do with. This next photo are pictures of these trees where the branches have been bent by the wind so much that they have created a curvature to them. Some were more defined, like the photo on the right. Some were in a tumbleweed looking kind of blob like the photo on the left hand side, but all the trees that were around it were kind of facing in the same direction. like the one on the left, how the tree is blown to the right. The tree branches of other ones were also going towards the right side. So I finally made it to the overlook. The next video that's about to play
So
is what I
here
saw when I
I
got
am at the
there.
top of Salado
Obviously,
Creek
you
in
can see the
Hardwicker Park.
trees, and as the video
As you can
pans
see,
down,
the
you
riverbed
can
is
see
empty
the
right now,
creek
which is
bed.
pretty common for this time of season.
I'm
So
sorry, the
here
video's having
I
trouble
am at the top
loading.
of Salado Creek in Hardwicker Park.
I'm just going to talk
As
about
you
it
can
and it'll
see, the
play as it
riverbed
goes, but
is
this is
empty
the
right
creek
now, which is
bed of
pretty common for
Salado
this time
Creek.
of season.
As you can
So
see, it
here
is a
I am at the
small,
top of
thin little
Salado Creek
trail
in
of
Hardwicker
rock
Park. As you
that
can
all
see, the
around it, I
riverbed
see
is
just
empty
grass
right
and
now, which is
roots
pretty common for
and
this time
tree
of season.
branches.
So here
Um,
I am at the top of
but
Salado Creek
obviously there
in
is no
Hardwicker Park.
water in this creek
As you
bed
can
right here.
see, the
The
riverbed is
video just ended,
empty
and the
right
next one
now,
that I'm
which is
about to
pretty common
play
for this time
is
of season.
of a
So
massive
really want
tree.
you to take
As you
notice
can
of
see
is
it right
right in
here,
front
it
of
is
me this
completely
giant
dead. The red
tree
circle is
that
certainly
fell.
the bottom of the tree where there is soil and roots holding it together, but it is obviously
Really
facing
want
up
you to
towards the
take
sky.
notice of is
So
right in
obviously
front of
some
me
sort of
this
weathering or
giant
erosion took
tree
place here
that
to
fell.
create such damage to this tree. I did not see anything that made me think that lightning had struck it.
Really want you to take notice of is right in
I
front of
decided I was
me
going to go
this
down there to check out the
giant
tree and
tree
check out the wall of
that
Salado
fell.
Creek and figure out what was going on with the creek bed. So this next picture is actually a rock that I saw that shows signs of obviously chemical weathering. But to me, the coloring that's on there is similar to oxidation, which is a process that ends with it looking like rust, which this looks like. However, as we know, oxidation is not common in San Antonio, Texas. In this next video that is playing, I am inside the creek bed. I came down that first photo on the left, and in the right video, I am looking around the creek bed, and I find where obviously you can see it is pretty much flat dirt all the way up that creek bed, and you can see where it's coming down in layers. It looks like stairs, but there are no big rocks, which tells me that when the creek comes, it comes and clears out all that dirt and debris towards the south because of gravity. This next slide is actually the creek bed. And you can see that that entire slab is covered and pounded with holes from carbonic rain acid. And that is because this rock is actually limestone, which is more susceptible to that. And some of these holes were deep, 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 and some were shallow. But that whole thing is just looks like little pellets had gone through it. This picture that I have posted is because it rained on Monday and Tuesday at the park. So, what little rain was there collected in this small area, which actually will bring me to the next video that I think shows clear signs of biological weathering. You can see right here where the um, rock has fallen down from above and plopped itself in the middle of that little stream section right there. And that's exactly where this little guy was hanging out with water. And that rock that was there did not have the holes like the other limestone did, which tells me it has not been there as long as these other rocks had. And it was wedged in that space pretty tightly. Because this is a creek bed, we do need to make sure that we do take special precautions. There were signs just like this flood exit sign all over the park and right when I entered the creek bed because of flash flooding, it does get very dangerous. As you can see in some of the next photos, you're going to see massive rocks that have trouble making their way down the creek bed because they don't have enough traction to make their way down there. In this next photo, however, I believe this shows two different things. I believe the photo on the left shows signs of chemical weathering. I'm sorry, biological weathering, because as you can see, the tree has grown inside that rock, and there is algae, there is indentions all over the rock from the water hitting it, from water erosion, from um, carbonic rain. But in this picture on the right hand side is actually different. The rock that is on the left hand side that is split in two, I believe that was caused by temperature weathering. And I say that because there's nothing inside them. There was no sign of vegetation inside. However, the rocks above it were had clear signs of obviously biological weathering from the tree and the roots breaking in through that rock and creating that. But again, I don't believe that's what happened to the rock on the bottom left hand side. This next video, oh, I'm sorry, this picture that I have in front is a picture of a rock with algae on it, which I thought was really interesting because there is nothing around this rock that has anything else to do with algae. Again, because this is a creek bed, when this gets flooded with water, the currents will flow so fast that it's going to drag the bigger rocks along the bottom of the bed creek, which is why usually on the side of the park and most of the videos I showed you, those areas are more susceptible to erosion because the water moves fastest on the outside of the curves. That's going to be the cut bank. And the when the water is full in the bed, it uses the currents to create traction to move heavier rocks, but it also uses small pieces like dirt and sand to dissolve and be suspended, while slightly bigger pebbles and stones will be in the bed load, bouncing around as they flow down, which will start to chip them into smaller pieces, making it easier for them to flow down the current. Because as we know, that water is like gravity, it just goes south, it goes down as much as it can. This picture that I have right here is a small piece of algae or moss of some sort. I'm not entirely sure, and I meant to take a picture after because when I cleared it away, this little sucker was embedded in the ground. He was rooted in there. So, how he came to be and is surviving in nothing but leaves, I'm not sure. But obviously, there is some water deep down underneath the rocks, probably groundwater that is holding in that water to help give that piece of moss or algae what it needs to survive. I started noticing as I walked the creek bed that because of the shade of the trees overhead, these rocks underneath were not nearly as weathered and did not have nearly as much carbonic acid rain done to them as previous because they weren't as exposed to the sun. They had water to catch that. Now, I continued walking the creek, but it started to get harder. And because of all the overgrown brush and broken branches and rocks, it got too complicated. And then there were massive spiders and webs, and I just couldn't make it down to the overlook. So I decided to make my way back through the creek bed to Harburger Park to head home. But as I did, I started finding these really cool rocks, and I'm going to present those to you in the next video.